Thank you for joining the technical inspection sessions. So we will start with the electrical inspection, and after that the mechanical one. First, to make it easier for you to show who is all on the team here in the electrical and the mechanical inspection, also D inspection. So the D inspection part you already had in the D inspection hour in the morning. So we'll only do the M and A and the accumulator and E inspection. If you have any questions for the D inspection, of course, you can also ask them here. We have both colleagues in the room, so don't ask anything you want. So I'm on the side. I try to keep everything together in the inspection. I'm not the expert in all the details, but I can answer some of the questions. So I also have for M inspection Christoph here. So he's sitting there. We can answer all the M inspection questions. We have Sarah for accumulator inspection and Simon for the electrical inspection. For D inspection, the guys are sitting in the back, Matthias and also Martin. So we're all there. So if you want to talk to anybody during the day, now you know who is responsible for what. All right. So first thing, scrutineering. Most of the things, it's actually boring, basically. So what is the whole goal of doing the scrutineering? And we hear often, the scrutineers, they're just searching until they find something. They're too strict, we're just 1 millimeter off, why are they complaining, and so on and so on. So I hope we will give you a bit more understanding why are we doing this whole thing. So first thing, of course, already mentioned in the first half hour of the day is safety. Of course, we want to make sure that everybody is safe during the event, especially you driving the car, and also the spectators. Then we have a rule book, so fair play. Of course, we want to give everybody the same chance to win competition in that sense. So fair play is then second part we do. But what you can also get out of the technical inspection, and especially preparing for technical inspection, is basically the good engineering practice. So what do I have to do to be a good engineer? So how do I look at my products, my design, and why am I designing it like this? And why are the rules like this? So ask yourself the question. It's not only I have to do it like this, there's a reason behind it. Often if you understand the reason, you understand what you need to do to design your car. So what I also want to say is that the scrutineers, they know what it is to be in a team, in a former student team. They're all ex-team members, so they also know the whole process, the pressure, and all the stuff that can happen. So they know what you're going through. So technical inspection, as I said, we want to have the car in safe condition. We make sure that all the requirements from the rules are being met. And what we especially say here, it's not a discussion event in that sense that we also want to progress the technical inspection, of course, really fast so that every team can go through technical inspection. And if you start a discussion, of course, you can ask a question and you can ask, no, why is this wrong or not, and so on, and we will give you an answer. But if you start trying to start a discussion to press your opinion and say that the scrutineer has to decide, otherwise it just costs you usually a lot of time and you will end up with the same decision. So also what we want to say is that if you pass the technical inspection at the beginning of the event, the car is checked at the moment. It's like an annual car review that you have to do for your car to be street legal. It's the same here. So if something changes on the car, it might be due to an defect, or if you change something on the car, maybe a setup, and you're not rule compliant anymore, for instance, the space between the ground and the lowest part of your car, then of course you're not compliant with the rules anymore. So at any point in the event, we can check. Usually it will happen after dynamic events. And then of course, if you not comply, we should do countermeasures. So in that sense also, what is new or more elaborately more elaborated in the rules now, is that also if you have a dynamic event, and for instance you do acceleration, you have the first try, you have the second try, and after the second try you're being picked out of the line and we check you, and then something is not compliant to the rules, then also the first run will also not be counted anymore because it's in the same dynamic event that you participated, and we can assume that in the first run it was also not in order. So make sure that also after you finish the event you still comply to the rules. So rules, I mean, the rules are there and we design them to give you as much freedom as possible. So you basically have the sandbox on the left and you have all the freedom to design your car as you like within, of course, the rules. What the rules are not, and sometimes we really see this from the rule requests that we get, is that the teams think that the rules are just like a prescription how to build a car. It's nothing like this. There are so many degrees of freedom, which is also good because it's a design competition. It's not built or painted by numbers or something. So also with the rule questions, so you can submit those questions. Also mentioned this morning, please think twice before sending in a question. So ask yourself, is this question to be this question, is the goal of this question to be more clear what is the rule meaning? So what is the rule for? If you cannot interpret it, yes, then you're right. Ask the question. If it's just a question like, look at my CID, is this rule compliant? Then we say, we cannot answer. So we're not there to just help you design the car in that sense. We help you to understand the rules, but not design the car. That is really your task to do in the year. So please think before you submit a rule question. As said, we get more than 3,000 rule questions. We have few people answering them. We try to do this as fast as possible, as good as possible. And it helps if these kind of questions that are unnecessary are already filled out in the submission process. So what we also have a few months, usually 2 months before the competition begins, we have the publication of all the tech inspection sheets. So what are the checklists that the scrutineers, so the techno inspectors use at the event and use them. I mean, it's like you do an exam and you already know the answers. So why shouldn't you take that thing, download it from the website, use it, and be critical on your own car. Use also old team members. Usually they're quite critical, they know how to design the car, and they can test you if you really comply with all the points that are being checked. What is also important is the visibility. Usually we see teams come with a picture, they say, oh yeah, it's already closed off now, but we have a picture of how we build it in. The rule really states, the rule book, that it needs to be visible. And if you can access it, it's even better. So that really helps to be quick in technical inspections and you prevent extra questions to be asked. Next to that is also quality of production. If you see like a cable, really a collection of cables just hanging loose, you spend less time designing it. So for us, this is the first warning, maybe we should look into it. And that's also helping us and helping the team to go further or faster through the whole inspection process. So try to think of it. So think of it, is it clean, is it neat, or does it look like we just put it together 5 minutes ago? What we had this year, so in 2018, we had the first time that we used the time slots. I had some positive feedback from that with the whole team, and we like to continue this for the coming season. So it's really, you have a fixed appointment, you know when to go to what scrutineering, and you will not have a collision with the times you have to go to the static events, for instance. And here we have a sum up of the times you get during accumulator inspections, 1.5 hour, electrical inspection, 2.5 hours, M inspection, 1.5 hour, and D inspection is only 50 minutes, but it will be combined with the M or E inspection. So it's just an extension of that. And if you need a re-scrutineering, we do it in the first come, first serve base. So we will continue this, and we will expand it probably also to the pre-inspection. So all the information you get here, and also the extra documents, extra decisions, rules, FAQs, and so on, it's all published on the website. And you can see it also as official interpretation, so it can be used by all the teams. So if it's official there, you can use it. You can use it for your interpretation, and hopefully it helps you more understand and build the car. Okay, I want to give you. Should I do this one? No, you step in. Okay, so this is the part for me. Now the electrical, the more detailed electrical technical inspection will start, and we just give you some examples of what you should think of and what helps you hopefully designing the car. So Simon, the floor is yours.
Okay, I will do the electrical technical stuff. And first, it's a mechanical thing, but as an electrical engineer, you have to know it as well. We have now a definition for fire retardant material. And really have checked this because you have an accumulator container, and all the years you have to build it with fire retardant material, and it's not that the sandwich structure or the container in a complete way has to be fire retardant. No, every single material, your foam, your everything. Yeah, so the carbon fiber, the glue, everything needs to be fire retardant. So the complete container, not just the sandwich structure if you have built it afterwards. And that's why it's a material test. And the material is just one material, not a composition of 5. Next, it's just for the combustion cars. I think the really problematic thing is the brake system plausibility device. But every year we have discussions what's standalone. And standalone is quite clear that there must not be any other functionality on this brake system plausibility device. No other function, no other interface than defined in the rules. Not even one additional pin for a status output. No, there's nothing else on this PCB. And if you put the PCB on top of another PCB, it's not really a good idea. A stacked PCB is counted as one. So check your brake system plausibility device or build a new one during the event, and it's always a hassle. Yes?
Stacked PCB means electrical connector.
Yeah, if you have board-to-board connectors, and then it's counted as one PCB. Next thing is must be directly supplied by the low voltage master switch. So if you have any box in between, this box is seen as brake system plausibility device. And if this box has additional functionality which is not needed for the brake system plausibility device, then it's not within the rules anymore. So if you have a fuse box or some stuff like this, check it and just take one wire, go to the supply, have a proper normal standard fuse, and you're fine. Yeah, the BSPD must not be inside the accumulator container. That's just to speed up scrutineering. And last one is that you have to prove the functionality. That means that you have to prove the functionality of the complete BSPD, everything which is needed for the brake system plausibility device. It's not that you can insert or supply some signal somewhere in the circuit. No, you have to check everything what's on the BSPD. The only thing you don't have to check, or which doesn't have to be checked, is commercially available current sensors. So if you have a commercially available current sensor with an output 0 to 5 volts, you can compute what's the threshold voltage for 5 kilowatts, and then you can supply this threshold voltage externally. But everything else needs to be checked. Okay, so now the E part, the nice part. First, if you think, is this within the rules? Isn't it? Use your brain and be reasonable. And if your brain says, it's not really safe, then it's not within the rules. I'm pretty sure it's not in the rules. If your brain says, it's safe, but it's a bit unfair, it's not within the rules, I'm sure. And only if you really don't know if it's within the rules or not, then you need to check it. One of now another rules. This year we defined galvanic isolation, and the galvanic isolation definition is near or is an adopted IMD definition, and that's why we have a resistance of 500 ohms per volt, and as in many industrial standards, there must be a withstand voltage which is 3 times the maximum tractive system voltage. And some of you already noticed how withstand voltage is not really defined. Yeah, it's not in the rules, but now you get a definition. We use the definition from an ISO standard for electric vehicles, and if your parts are within that definition, you're fine. If not, then you have to dive into the withstand voltage topic, and if you want to be really sure, you have to do a rules question. But if your parts are within that definition, you're fine. In general, or normally, automotive parts fulfill this definition. The rules for the tractive system active light, they changed slightly. And what changed is that there is now an explicit safe state defined. And the definition for the safe state is off. This morning I already described why we define it that way, because if your low voltage system is malfunctioning, your battery is dying, then you cannot turn on a red blinking tractive system active light. So the only possible safe state is off, and red is indicating an activated tractive system and low voltage activated, and green is indicating a deactivated tractive system. So if you're working on the car or handling the car, only green is safe. If there's no T-cell at all, it's not safe. It's not a safe state. You have to know what your car is doing. Yeah, okay. And then there's the single point of failure rule. This rule means that if there's any device breaking in your tractive system active light or the circuitry needed for that, it must not indicate a deactivated tractive system if it's not deactivated. So if your wire between the air detection circuitry and the rest of the T-cell breaks, then you must not enter the green state. Or if there's a MOSFET or any other transistor breaking, failing, then it must not be possible to have a green light on, even if the attractive system is not deactivated. So you don't have to do it complete redundancy. It's just check that the green light is really exclusively illuminated if the attractive system is deactivated. Here, it's the new thing is that the driver has to have his own indicator because a driver doesn't see the attractive system active light. And there was some feedback that it would be nice to have such an indicator, and yes, here it is. Great idea. Last year it wasn't that explicit in the rules. Now it's explicitly stated in the rules that the attractive system active light, even the check for the accumulator insulation relays, the state of them, must still galvanically isolate the inside of the accumulator to the outside, to the vehicle side of the accumulator. Especially for those of you who had very low resistances for this circuitry, you might have to redesign your T-cell. Yeah, and there's a redundant voltage measurement. That's just because it's impossible to detect, or it's not impossible, but it's hard to detect an open circuit for voltage measurement wires. And that's why we decided, yeah, we do a redundant measurement for all teams, then it's easier to check for us, and you know what to do. Yeah. Last year, yes?
One question to the states of T-cell.
Yeah.
The last column shows off for both. Both means green and red at the same time illuminated?
Yeah, it's a failure, yes.
So both and off are considered as the same state?
No.
Okay.
But I want to say that off is the default defined safe state. But for the single point of failure, it might be possible that, for example, the green light will illuminate and the red one is blinking because you have one device breaking, one IC device. And then it's not, if both are illuminated, it's not green, so it doesn't indicate a deactivated attractive system. It's just an unknown state. Here, the safe state of the T-cell is just off. Sorry for that. Slide from last year. Still, watch out for the mounting of the T-cell. The complete T-cell is a T-cell, and the T-cell must be in the rollover protected envelope, and the mounting is included. And there, there's this small, tiny replacement device for the accumulator. If you disconnect your accumulator, then you have an open circuit for the stuck air detection, and then the T-cell will enter safe state, hopefully, if you do it well. But you aren't allowed to work on the car anymore because the T-cell shows that the car is in safe state unknown, and that's unfortunate. That's why you have to have a replacement device, which logically replaces the stuck air detection. What I want to tell you as well is that please, it's not required by the rules, but it would be a good practice to have a kind of an analog TSAL, just a cone or a sign, for example, a green cone. You can put on the car when the low voltage is switched off, but the attractive system is deactivated. And then you can put the cone on the nose of the car, and the master switch is on this cone, so you cannot activate the car without removing that cone. And then you have kind of an analog tractive system active light, and every team member can see, okay, this car is safe. Our ISO has declared it safe on its screen. And if this cone isn't on the car, or the car is low voltage system is on, and the cone is on the car, then you know, whoa, something is wrong. And then you have always a well-defined state of your car. Everyone can see it's safe or it's unsafe. Cone on the nose, a green cone on the nose with a master switch safe. No green cone and no green tractive system active light. No work on the car. Yeah, the grounding rule changed. You don't have to ground everything, and I hope that will ease your design process. And this rule is much more reasonable, I think, now. And there were some issues with reels, and the formulation is very, very unfortunate in the rules. And the intent of this new rule is that you don't have to ground the wheels. So the rim doesn't need to be grounded because it's almost impossible, and there are other just you don't have to do it. For this year, a new thing is that your insulation monitoring device needs to be properly connected to the car. There are two ground measurement lines, and often in last years, teams just connected them, and so they directly short-circuit them and then connected one of the two lines to a vehicle ground. Yeah, it works, but it's not the intent. The idea is that the ground connection is checked by the IMD as well. So it has two connections to be able to check if its ground connection is properly done. And if you're just short-circuiting both, then this functionality isn't working anymore, and it's impossible for the IMD to notice if the connection to ground fails. That's why now the rules require to connect one of those measurement lines to the accumulator container and the other one to the main hoop by two exclusive wires. It's just that the IMD works as intended. The outboard wheel motor wiring rule changed. On my point of view, it changed slightly. I think for some teams, please check your design, because that could be and will be a showstopper. You cannot change, or often you cannot change your tractive system wiring within a day. Or mostly you can, but it's a pain in the ass. And please check your wiring if it's according to the rules. I don't want to have the tears during the event. We changed the temperature rating, another nice thing, I hope, for the tractive system connections, wiring, insulation to 85 degrees. So it went down from 90 to 85 because that's a more common threshold or temperature range. So you're able to use more different devices and insulation materials. But as well, there's still this good engineering practice and other rules. Please check that everything you're using is designed for the surrounding temperature or for the temperature it's used. For example, your discharge might heat up. So everything around the discharge must be designed for that temperature. A never-ending story. Every year the plastic rule, if you have, for any connection, you must not use plastics in a stack up. The idea is that if you have plastics in a stack up, so there's a bus bar and another bus bar and a bolt through both bus bars, pushing them together so that you have a pressure between them and a good connection. That's nice, but if you have plastics in between, so the force must first go through the plastics and then to the bus bar plastics bolt, then this might be bad, because the plastic might heat up due to the resistance from the connection resistance, and then the bus bar, the plastics melts or changes its thickness, and then the pressure on the bus bars will decrease, the resistance will increase, the plastic will even heat more up and will get thinner and thinner and thinner, and your car burns. So don't do it. For connectors, as every year, keep in mind that withstand voltage is not rated voltage. There are some standards where you can compute your rated voltage, or you can use rules of thumb from the British standards. I think there was this 1/3 of the withstand voltage is a good indicator for rated voltage, but withstand voltage is not rated voltage. So if you have a 1 kilovolt Deutsch connector, it's normally not a good idea to use it for 600 volt tractor system. Yeah, and now Sarah will continue. Willst du das?
Okay, I will come to the next part. Like everybody knows, we still use the energy meter or data logger. You should not put it inside the accumulator container, and it has to be taken out and taken in within 15 minutes, because you always complain you can't change it if something breaks inside. But it's your issue. You have 15 minutes, and if you can't change it, it's not our problem. And please look that you don't have so much EMC around it and it's not working. Because last year we were nice, we were giving you old energy meters, especially for the driverless teams, but this year not anymore. So if you have a car with issues, try to fix it, because most teams work, we try to solve our issues, and there shouldn't be any. So please look into this issue, especially the driverless teams. Something else what's gonna change, we want to make the temperature measurement different. It's not 100% sure, we're right now in the designing phase. A real update with all the information will come in the middle of January, so after registration. But please prepare both versions. I think most likely we will use the new version. So you need new interfaces. We get some CAN data from the sensors in the accumulator container. You get a little box. You measure everything, and then you put a CAN outside the accumulator containers to the energy meter. And we put something more in the energy meter box, and then we can read all the data out with the Ethernet cable. So that's one time you stop somewhere and we get all the data we need. We maybe use the sensor what's on the picture, and when we were there, we will put 3 of them in each accumulator container. So if you have 2 containers, you will have 6 sensors and 2 boxes. So please prepare some space. Right now we only say it will be half of the size of the energy meter data logger. It will be smaller for sure, but we're still in the designing phase, and I don't want to make any promises which direction we go. So I say, prepare the space and you will be safe. And you will get more information in the middle of January. So don't worry. But the position where we put sensors, we will fix. We will tell you to, or with you. So you can't choose the position free. I think that's the biggest change in the accumulator part for next season. That also will apply to the driverless teams, so you have something to do. Yep.
So the position box is supplied by the event.
The box we will give you, the little box, and the sensors we will have too.
And where the box has to be positioned inside the accumulator
inside the accumulator container, to the small box, yes.
And the connection from the sensor to the position box is made by ourselves.
We will give you more information, but I think we will have sensors with cables to the box. But you have to prepare from the box to your energy meter some cables, like one cable with CAN and with power supply, because it's coming from the energy meter box. That's what you have to prepare. Yes? No, it has its own. It goes to the energy meter, and you're not allowed to look at the data or do anything. It has to be a single connection with the information from this to the energy meter. We don't want to go over your bus, because then you could change our data to anything you want to do. So then we don't have to do anything anymore. So we double check this. And we will send also some different data to prove that you don't interrupt something from our data. But you will get more information, but I want to let you know for your design period right now. Okay. Then I come to accumulator scrutineering, good practice. We had last year some issues. Normally, if you think with your brain, they shouldn't be there. But you should know English. And then one ISO at least should be able to speak English. A translator is a good option, but if the translator doesn't know technical words, it's impossible or really hard. So please practice your English, try and learn English, so we can communicate to you. Then it would be good if you know something about your accumulator, if you ask some questions. You laugh, but we had some people who didn't know what's inside, had to search for main plugs and so on, because they didn't open it, because other people worked on it. Please double check, because it's our time and the time from your team. Please be prepared. It's basic. And the next thing is have efficient documentation. So if you want to show us something is hidden, what you do in an accumulator container. So please your documentation. I don't care, paper or on a tablet or laptop, but please bring it. Also, if you manufacture something, we don't want to take the whole accumulator apart to check everything. Bring pictures so we can see something on pictures, compared with some parts of the accumulator and go on. If you don't bring anything, you have to disassemble everything, and it takes a long, long time. So please prepare everything. Make more pictures and bring them along. Also, you have to be able to take a cell stack out of the container so we can look if your design fits what we described in ESF, or describe what you said and if it's safe. If you say it's impossible to disassemble, then it's impossible to drive on the event. That belongs to both parts, to every electric team. And also what is nice, what you should do to save time, if you put a fuse inside, maybe put it in a direction we can read what is standing on the fuse to check if you use the right one, or just put any fuse inside. Also, with all the other stuff we want to check. So just don't put it somewhere hidden down there, because it takes a long, long time, and you're wasting your time in scrutineering, and then you're wasting your time to fix stuff. So then we come to a problem what we have every year, and we have every year the same discussion, accumulator indicator light. Every year you come to me and ask me, how light has it be? How can I measure it? The light has to be visible. If you're in the tent and if I have to search if it's on or not, it's not in bright sunlight visible. I didn't write there how many looms it has to have. We have to see it. And if there's a discussion if we see it or not, you probably know the answer. It's not good enough. So please fix it. You can try it before. Put it somewhere and ask somebody if you see it. And then we come to the current main path. We saw this year some current main paths, they were moving. So if your car was driving, it could move up and down, it can move around, it was between cells. And we had interesting versions, how teams did it. Please make sure. It's your current main path in accumulator. It should be safe. So safe, so fitted, so it can't move, mounted safe. Make it in a safe way. Please think about it. It's not nice if the car drives over something and it can move up and down or to the side if you brake. You won't pass scrutineering this way. And another topic are the maintenance plugs. Maintenance plugs should be you should easily take them out when you work on the car. So if you need 1 hour to take your maintenance plugs out, it's not a good way to connect it. And the most important thing, what most teams do wrong, you can correct it in the wrong way. So you can short circuit your own accumulator. Please check that you can't do it and make some protection, because it's not only for our event, it's safe for you at home. Maybe you're a little bit tired, or something is wrong with you, or somebody's helping you and connecting in the wrong way. You can break something and can injure yourself. So please double check. It's something easy, but work on it. And also, if you work not on your accumulator, cover the parts. You have blankets, you have everything. Because sometimes, not this year, 2 years ago, one team just let fall some tools on the accumulator and short circuit, and then they broke something and they couldn't drive anymore. So please protect yourself and all other people. Not only at FSG, do it at home. And one big issue we have every year, we have cells. Cells are there for the cells tabs are there for the electrical connection. Please don't mechanical load them. They're not there for holding the cells in place. They're not there for protect them from moving up and down. They're not there to hold on this part of the cell that's not moving right or left. They're just there to connect each other. So please take all the mechanical loads away from the cell tabs. That's the biggest issue we saw, and a lot of teams had to fix it last year. So please think twice. And if you think there could be a little bit load on, ask the mechanical guy and double check. If not, you will have an issue. What's really hard to fix on scrutineering and takes a lot of time. Also think about other forces, what you don't think occur when you have a crash or something like this. We will look at the other forces as well in scrutineering. That's really important. And I hope I don't see it this year again. And then we had an issue. We have a hand card. You all put all stuff on you want to put on, mostly more than you need, and your accumulator container as well. Please just put stuff on you actually need in scrutineering, what's really important. Leave all the rest in the box or with your teammates. And second of all, put your accumulator on the hand card so it can't fall down, because we have a little hill and something to get to the accumulator tent. Hockenheim won't fix it, so it will be still there next season. So please fix your accumulator container so it stays on the car. If it goes slightly down, has a small bump and goes up again. If you don't have it fixed, you won't drive your car. It's not. We look at this year in scrutineering. So if your accumulator container is not fixed good on the hand card, you won't drive on the event. So it's not just something nice to have. You have to do it because something can break. And also what's important, we store your accumulator containers on the hand card. We say you put your team name and your phone number on. Put it on that we can read it. We don't want to lift your accumulator, take it away from the hand card to see your phone number. Sometimes it can happen something in the accumulator tent and we have to reach you. So put it somewhere we can read it, and then I'm fine. And then also try to work always with the proper tools, double check and be safe. Because if you do something wrong, something can happen really, really quickly. So please double check if the tools are correct all the time and just work with these tools. If you see somebody else screwing up, tell them how to do it, talk to them. Because we can't have our eyes and ears everywhere, so please help everybody to stay safe. And even stay home safe. And wear proper clothing, because always something can happen what you don't intend to happen. And that's it from our side. Now, if you have questions, you can ask us.
Okay. I don't know how much time we have.
15 minutes.
14 minutes. Oh, we can discuss the whole rules book. If you have rules questions, then now there is the possibility to ask. Or if you have questions to electrical scrutineering or your electric car design or whatever. Yes.
So, if I understood it right, you do not have to detect an open circuit on the TSAR voltage measuring inputs because you have one at the inverter and one into the accumulator. You only have to detect an implausibility if they are out of phase.
No.
Okay.
You have to detect an open circuit, but it's much easier because you have two measurements, and if you have one open circuit, your measurement is normally not plausible anymore.
Yes, okay, that's what I understood. Thanks.
In the accumulator container, will you mount the temperature logging devices on the bus bar or on the cell tabs?
We will look where the temperature is the highest in the accumulator container. Could be on both, could be either one. So we will check on your design, how you design your accumulator container when you hand in the ESF.
Okay, thanks.
Yeah, about the box for old accumulator containers, according to driverless vehicles, yeah, there might be some problems because the box won't fit in the container anymore. Yeah.
Like, we think it should be possible to fit in. If you have some issues with the driverless ones, then you have to send a rules request and we will try to find a solution. And it won't be so big how we describe it now, so don't worry.
Yeah, then probably there are other rules as well which aren't met, I'm pretty sure.
The IMD ground one must go to the main hoop. I got a question. When we use a steel chassis, do we still need to put a cable on the main hoop, or can we use the nearest grounding point?
Yeah, you can connect it somewhere on your chassis because it's a separate conductor. Yeah.
Okay.
It just doesn't work with monocoque cars.
The routes say that the arrow LEDs for IMD and AMS needs to be seen from outside of the cockpit.
Yes.
How is this defined outside of the cockpit?
If you're not inside, then you're outside.
Yeah. So do you need it to see from the front? That's the question.
I think you did a rules question for that.
A colleague of me. Yeah.
Yeah, there answered. It's if you're standing next to the car.
Okay.
So it's not, the idea is not that if you're 20 meters away. No, it's you're standing next to the driver, and then you have to be able to see.
Okay.
So you're standing left or right.
We are planning to have some cooling fins between the accumulator packs, so that the pouches, they are most likely going to be made of metal, obviously. Do we have to ground them?
Yes.
Okay.
If the cooling fans are made of metal and
between the pouches.
and the fins. Yeah. Everything needs to be grounded. It's a standard grounding rule.
So you redefined the rules for galvanic isolation. Must the value for the ohmic resistance stand in the datasheet, or is it possible to measure it for the whole part? So it's in special for our inverter?
Yes.
And there is one part inside where the resistance is not given in the datasheet for this single part. And is the resistance measured for the whole car, or how will this be measured? The resistance between...
Yeah, but normally the resistance is a few max, so
Of course, but do you need the special
No.
value for it?
No.
Okay. Just the voltage.
Yeah, if it's below 500 ohms per volt, then you have a problem anyway.
Yeah, of course, yeah. But yeah, the question was if it has to stand in the data
No.
sheet, but that does.
No.
Thank you.
The galvanic isolation rule is only, or is interesting, especially for the stuck air detection. There you have to design your stuck air detection in a way that it's still within the galvanic isolation rule. And that's why we made it. Yeah. So there are no questions about the outboard wheel motors. Nice. Yes. So it's a good rule, I think. No more questions? Perfect. Then.
See you in Hockenheim.
Yeah. Thanks for listening, and see you in the summer.